Hi, thanks for joining. We're going to talk about productionizing data and ML projects. I'm here with Michelle, and my name is Matthew Seal. I'm the CTO and co-founder here at Noteable. And my background overlaps with Michelle back at Netflix, where we both worked on the big data team, working on different data problems, and overlapped a lot on the intersection where notebooks helped advance that. And on that note, I'm deeply involved in the Jupyter community space. I'm a distributed contributor there, and I've been working in the open source as much as I can.
Hey everyone, my name is Michelle Ufford and I'm the CEO and co-founder of Noteable. My background is all things data. I've been working with data for the last 20 plus years. And right before launching this startup, I was at Netflix where I led the big data tools team, which was really focused on innovations to improve the usability of the overall Netflix data platform. So like I said, I've been doing this for a little while, and I thought it might be helpful just to take a quick look at how data lifecycles have looked traditionally. So I'm assuming that you've all seen something that looks very similar to this. It's largely unchanged for the last decade plus. And it doesn't really matter what your role is or what your specific data project is. Most data projects will follow a very similar path, which is that you start off with your data discovery, trying to understand what data is available and what does it mean. And then you get to your data prep phase. And this is the point at which you do any sort of integrations, denormalizations, transformations, all of that work takes place here. And you often spend a lot of time in this phase. Then once you have your data available, you're ready to go on to your model definition phase. So you get to your model planning, you iterate back and forth between the data and the design until you're happy with what you have. And now you're ready to get to the building phase. And so the building phase is where you do the core of your development. Now, this is a very generalized view. Obviously, if we're talking about machine learning, you need to have training in there. And when you're talking about machine learning, you've got this highly iterative loop that actually goes from the definition phase to the building phase to that model training phase, rinse and repeat as many times as you need to. But we're going to go back to that other view just because it's a little bit simpler for us to work from. And so once you're done with your development phase, now you're ready to communicate those results out. So you've done your analysis, you think things look good. You're going to probably put together maybe a memo or a Tableau report, and you really want to communicate out to your business partners and stakeholders what you've created and get the go ahead to deploy this to production. And so once you do get that go ahead, now you're ready to operationalize. And this is the point in the process where you will do all of the transformations you need to get this really ready for production. So when you're doing development, oftentimes you're doing an ad hoc or a one-off type of development process. Now you need to make this entire thing repeatable. You also might have to change the language from maybe like a SQL or an R to something like a Python or a Scala. So all of that takes place there. And then now you're ready to deploy this to production. And so once we're ready to get to production, we need to both ensure that what gets deployed is what we think is deployed, and we need to make sure that it continues to stay good. So we're going to put any sort of quality checks in place, canary test, all of that's going to take place as part of this productionalization. So this works pretty well. We've been doing this for a while now, but what happens when there's a problem, right? It gets pretty painful pretty quickly. Because now you're dealing with, let's say that you did have to do some sort of language transformation. Now you're dealing with multiple artifacts, with multiple people. You've got your model owner who is writing the code in R or Python. You've got to involve your data engineer who is probably working in Scala or Python. If you have a DevOps person, you might need to involve them too because they're helping with the deployment. And so this is a really slow and tedious and painful process. And it can take hours just to figure out what's going on, what went wrong, let alone not even get a chance to fix it. So if you're feeling this pain, rest assured you are not alone. We've all been feeling this pain. And so we've started to see this life cycle evolve. All right, Matt, you want to take it from here?
Yeah, thanks. So largely, the data lifecycle as you see it really hasn't changed in shape in terms of what your process is that you need to go through, walking from discovery through operationalization. What's really actually changed is the fact that the friction points of moving from each of these steps has become a bottleneck to be able to do more work in data space. In today's world, you might have more bubbles here. These bubbles might be expanded. You might add stages to this process. But at the end of the day, you're still doing a development feedback loop cycle that you go through. And what we found was that the place where you really helped solve the friction points that were coming from the traditional cycle was around finding a unifying tool or interface that really brings what's in production to be closer to what you do in dev. So the further your development process is from what actually is going to run in production, the harder it is to respond to issues, come back to problems after they've sat outside of your development cycle for a while, and the harder it is for the start the next project. You really run into all sorts of friction points around the time to resolve and iterate being a function of each of these stages having different tool chains, even different languages or different systems under the hood. So we go back to that problem Michelle described. You have a problem in production. Well, if you have a unifying tool, you can actually take what was in production, feed in the original inputs that actually caused that problem, and then have an end resolution where you can, in development, reproduce the problem right away, identify where the actual issue is, and then get the right people focused on fixing it. And if you do this well, you can even have people who weren't involved in the original development know how to fix it because you have a similar interface, a similar tool chain, and everything looks the same. So take, for example, what we did at Netflix, which we use notebooks for this use case a lot. You take that problem statement you have, and this is a Jupyter notebook. And if you have that like kind of production flow run as a notebook, when it fails, you can actually see the notebook with the given inputs, with the given logs, the given visualizations, all there, and it's reproducible. So I can right away take the outcome result that failed or had a problem, rerun that locally or rerun a subset of the data locally against that, and identify exactly what I need to do. Also, if the problem is somewhere else along your development lifecycle chain, even all the way to communicating results, it's really easy to share the same document, the same interface to solve for the same problems. And we found this greatly reduced the friction on having smaller teams able to support more data pipelines. You could have one person who supported many more pipelines, so when something went wrong, other people could lean in and help, and also that one person could be more effective. So I talked about different unifying tools. Notebooks is the one that we've used a lot, but there are other ones out there too, especially in the ML space. You have something like Metaflow, which is an open source library out of Netflix, or MLflow, or some of the others. A lot of them all have the flow phrase in them because they're really talking about how you need to flow from each stage of your production cycle and bring the tool along as you go. And what this really does is it flips the focus of what you need to work on to productionize your work. Before, you would always productionize the last stage because that was the closest to production. But now in your development is close to production pattern, you can actually focus on like standard software development best practices that will improve both the dev and production's life cycles. So you can do things like unit testing, code cleanup, documentation, those types of things now benefit both halves of that equation if you have a tool in the interface that keeps those two locations similar. Stepping to that notebook example where we really had a lot of success in bringing that together for all data users was, I wanted to talk some about the tools that are available in that space. What does productionization with a notebook look like? Well, beyond the standard kind of code cleanup and documentation paths you would do with code that you can do with the notebook, there's also some newer things like Testbook, which I'll talk about in a minute, as well as lots and lots of options for documentation and other testing and parameterization controls. Papermill was something we worked on at Netflix in the open source, and that had a lot of success for helping with the integration parameterization aspect of it. But there's lots of other tools here that you can use to kind of promote a notebook beyond the development cycle. I wanted to talk briefly about Testbook. This is a project that I worked on with Rohit in a Google Summer of Code last year. And this came out really great. It's a tool that allows you to write unit tests against IPMYB notebook files, just like they were .py files. So you can see from the document page snapshot here that you can write a simple test against a notebook and actually unit test the contents within a notebook rather than the full notebook end to end. And this unlocks some of the use cases where you have more complicated notebooks and you need to figure out how to split them up or test them better. And that's a really handy library if you haven't seen it.
So that's our talk. Thanks everybody for watching. I know it was a lot of content really quickly. So Matt, myself, and members of the Notable team are going to be on the conference Slack and on Twitter if you have any questions about any of this or anything that we can do to help.
And if you want to find out more about how we're using notebooks to help with data and ML workflows, sign up for our beta. That's going to be launching soon, and we'll love to talk to you afterwards.